Hi. So in this example, we are going to look at sequence, selection and repetition. Alright, so what is the requirement? We want to print a 7 times table starting from 7 times 1 equals to 7 up to 7 times 10 equals to 70. Alright, so what do we want? So we want to print this 7 times 1 equals to 7, 7 times 2 equals to 14, okay, all the way until 7 times 10 equals to 70. Okay, this is what we want to print. Alright, so we are going to run this as what we call in coding a loop. Alright, we are repeating the same set of code multiple times until some exit condition has been fulfilled. Alright, so of course this concept on what is a loop, what is exit condition, variables, all of that we will cover more, okay, in the coding. But for now, we are trying to understand the thought process, the logic, so that we know how to implement the correct algorithm and the flowchart. Alright, so in a times table, alright, in this example, the 7, since we are printing a 7 times table, 7 is fixed. So the number that is changing is this second number, and based on the second number, we will generate an answer. Correct? So this second number, okay, I'm going to call it count, and I'm going to initialize it to a value of 1. Alright, so what is going to happen? Once I initialize it to a count of 1, I will check whether the count is less than equals to 10. Why? Because I only want to print until this last entry here. Okay, as long as count is less than equals to 10, alright, this second number is lesser than or equal to 10, I want to compute and print the result. So I will print 7 times count. So the very first time count is 1. Okay, so then I will print this line, 7 times 1 equals to 7. Alright, and I want to increase my count by 1 because once I print 7 times 1, I want to print 7 times 2. Correct, so from 1, I must increase by 1 to 2. Correct. And then I go back to step 3. So this is where the loop comes in, or the repetition comes in. So when I go back to step 3, I check again, is my count less than 10? So currently, initial value of my count is 1. Okay, I print the first line. Next, when I go and increment count, in this step, count will become 2. Alright, and then I go back, I check, is this condition satisfied? Then, as long as it's satisfied, I print. Alright, and after I print, what do? I increase to 3. Alright, I increase to 3, and then I go back to step 3 and I check again. Okay, now this will keep on repeating, okay, until this 7 times 10. Alright, so at some point of time, I will go until count will become 10. After I print this line, okay, 7 times 10 equals to 70, what happens? Count will increase by 1 to 11. Now when count increases by 1 to 11, when I try to do this check, okay, or when I perform this check, count, if count is less than equals to 10, what will happen? This condition is no longer satisfied. Correct, it's no longer satisfied, which means I will skip all of these steps of 4a and 4b and repeating. Alright, so this condition is no longer satisfied, so instead of doing the if, I will do the else, which is print end, alright, and stop. Okay, so this print end is just something that I put, okay, as some action to do. But if you don't want to print anything, you can also go straight to step 5, which is to stop the program. Alright, so this is the idea, the thought process. Okay, so let's go ahead to implement the flowchart. Alright, so the start is already given there, okay, in the flowchart. So after I start the application, the first step is to initialize the variable. So initializing is again some action. Alright, so I'm going to draw out the rectangle and I'm just going to say count equals to 1. Okay, after I initialize count to 1, I'm going to check whether count is less than equals to 10. So as we saw before, checking or decision making is basically the selection block, which is the diamond. Okay, so I'm going to check whether count is lesser than equals to 10. Alright, now if this condition is satisfied, what do I do? Okay, I must print 7 times count equals to result and then increment the account. Okay, so to print, all right, I'm going to have an output. So I'm going to say print, okay, 7 times count equals to result. Okay, now of course, rightfully we need to calculate the result first, correct? So if you want, okay, you can break it up into 2 separate steps, okay, and I can say that the first step would be to compute the result. Okay, so I can say result equals to 7 times count. Okay, so since that is a computation block, I use the rectangle, and to print out I can just say print result. Okay, so again, there are different ways in which you can break up the flowchart. Alright, so in this case, if you want a bit more detail in each step, you can say that I break it up into separate steps where I first compute the result and then I print out. Okay, so computation is a rectangle block, printing is an output, so I use a parallelogram. Now after that, I need to increase my count by 1, correct? So that is a computation block. Okay, so I'm going to put this over here, and I'm going to say count equals to count plus 1. Okay, so what is happening? I'm increasing count by 1. Every time I print the result, I increase count by 1 to prepare for the next print. Okay, so let's draw the arrows first. Okay, so we are clear what is happening. Okay, now this arrow, I proceed. Okay, if count less than equals to 10, this I proceed only when the result of this check is true. So I'm going to put a label here and I say true. That means if count is less than equal to 10, then I proceed to do this. Okay, and after I increase my count by 1, what do? I repeat step 3. So I go back. Okay, so I draw an arrow. Okay, and where do I draw the arrow from? I draw the arrow back to here. Okay, so you can fine tune the positioning of the arrow to make it neat, okay, and straight. Okay, so what is happening? Okay, if you look at this pathway, when count is less than or equals to 10 and this condition is true, I will compute the result, I will print it out, I will increment my count and go back again. Okay, this means I will keep repeating this loop, correct, until the last print, which is 7 times 10. Now when 7 times 10 is printed out, alright, I increase my count by 1, it becomes 11. Okay, and at that point of time, this check will return a false. Okay, to return once it returns a false, what do? I just print end and I stop the application. So I can have another block here that says print end. Okay, and then we stop. Okay, so let me draw the arrow. Okay, and then here I just go to end. Okay, so I add one more block here, call end or stop. Alright. Okay, and that would be the end of the entire application here. Alright, so this gives you an idea of how the flowchart is designed, okay, for an application like this. And this is considered a flowchart that contains both sequence, correct, because it's step by step, selection, alright, because over here we need to do a selection, and repetition, okay, because from here there's an arrow going back. So whenever there's an arrow going back, we consider it a repetition. Okay, so there's one more thing that we haven't done. We need to label this arrow as well. So this is the false arrow. Okay, why? Because when I do this check, if count is less than or equals to 10, there are two pathways. One is true, the other is false. Okay, true and false. So I need to decide, okay, based on this check, which pathway I'm going. If count is less than equals to 10, I take the true pathway, which is to compute the result, print it out, and increment my count. If it is false, I just print n and I stop the program. Okay, so this is the idea, alright, of a flowchart that contains both sequence, selection, and repetition, all three. Alright, so this gives you, okay, so with all these three videos, okay, you have an idea of the different types of flowcharts. Alright, once we start the coding, okay, in Python, we will learn the different concepts, okay, that are needed to implement the correct code for all these different types of flowcharts. Alright, so thank you for watching. I will see you soon in my next video. Bye.